we're looking for the critical points of this function, and critical points can be found where the first derivative of our function equals 0 or where that first derivative is undefined. With critical points, we're looking for maximum and minimum values of a function. More specifically, we're looking for local minimum and maximum values of a function, and we can see that local maximum and minimum values happen on this particular function at these 4 points. And at this local maximum and this local minimum, you can see that the first derivative of this function is 0 because it has a horizontal tangent line there. At this local maximum or this local minimum, you can see that the first derivative of this function does not exist because this local maximum happens at what we call a cusp, and this one down here happens at what we call a corner. And in both cases, our first derivative does not exist there. Okay, so that's just a really quick mini lecture about critical points. Let's go ahead and find those critical points of this function. Our first step is taking a first derivative of the function. In this case, that means using our power rule. We're going to take this power of 2 and multiply it by this 2 to give us a 4. Then we're going to reduce the exponent on x from a 2 to a 1. So the derivative of that first term gives us 4x. The derivative of negative 3x is negative 3, and the derivative of negative 4 is 0. Now our critical points occur where this derivative is either 0 or it's undefined. Well, this first derivative is just a linear function, so it's always defined. There are no denominators. So the only critical points we're going to find here are where this first derivative are equal to 0. This is now an equation that we can solve for x simply by adding 3 to both sides and then dividing both sides of the equation by 4. So we have one critical point, and it occurs when x equals 3/4. I believe that this is the answer that we're looking for in this particular problem. But if we actually want to find the critical point, a point has a y value as well as an x value. So if we wanted to find that y value of that critical point, what we would do is we would take the original function and we would plug in x equals 3/4. The notation for that is f of 3/4. I'm going to zoom out to make a little bit of room here, and the following is just going to be fraction work. So I'll kind of speed through it. You can hit pause on your video whenever you want to if you want to take a closer look at this work. So I found that the y value of this critical point is negative 41/8. So our critical point with both its x and its y value would look just like this right here. Okay, I hope that this problem helps you get started with critical points. We'll do another problem in the next video, so I will see you there soon.